Welcome to this lesson on equivalent ratios. So this is a really important idea in ratios. It's the idea of equivalence. So just like you can have equivalent fractions, you can have equivalent ratios, because really fractions and ratios are sort of the same thing. So consider these three ratios: 12 to 4, 3 to 1, and 30 to 10. So we're going to notice something about these. But first we're going to just talk about this idea that ratios are called equivalent if the quotient of the terms is the same. So that means that if we basically look at the relationship here by division, and we do the same with these other ratios, we should see that they have the same quotient. So that means that if we divide those, they end up with the same quotient. All right, so we have 12 divided by 4, and that gives us 3. We have 3 divided by 1, and well, that gives us 3 also. And 30 divided by 10, same thing. These all give us 3. So what does that tell us? It tells us that the ratios 12 to 4, 3 to 1, and 30 to 10 are all equivalent, for the same reason that we might write 12 over 4 is equal to 3 over 1 equals 30 over 10. These are all equivalent to each other. So the skill here for you to consider is creating and noticing equivalent fractions. So consider just this example where we have this growing pattern, 1 to 3. Kind of the reverse of this one. And if we look here, we've created a chart, just called a T-chart, that we can use to compare equivalent ratios. So consider the first example. That's a 1 to 3 ratio. Notice if we double both the circles and the x's, we get 2 to 6. Our pattern continues, 3 to 9. Our pattern continues, 4 to 12. And you see that same equivalent ratio from the above example. We could continue this pattern to get down to 10 to 30 if we really wanted to. So what we might notice is that there's a rule here. So the first rule we'll notice is that going from left to right is always a divide by 3. Going from right to left. So going this way, there's always a division by 3. So every single one of these equivalent ratios, one term divides by 3 to give the other term. You might also notice that in between two equivalent ratios, you can find a common factor. So here, going from 1 to 2 is doubling. Going from 3 to 6 is doubling. And so these link these together as equivalent ratios. If you consider going down the table, so say from 12 down to 6, this is a divide by 2. 12 divided by 2 is equal to 6, and 4 divided by 2 is equal to 2. So there's a relationship between all of these equivalent ratios. We say they're all equivalent to each other. What you're going to do is practice looking at a single ratio, creating equivalent ratios that go with it, and noticing the patterns that you create as you do that, and then seeing if you can find out if a ratio is equivalent to another one by the same kind of thinking. I'll see you in the next video.